In this lesson, we'll be learning to solve systems of linear equations graphically. A system of linear equations just means a group of linear equations. To solve a system of equations, what we are looking for is the points at which the different lines or equations intersect with each other. In our first example, we will start with two equations, y equals x plus 2 and y equals negative x plus 4. So first of all, we'll graph y equals x plus 2, which means it has a slope of positive 1 and a y-intercept of 2. Then we will graph y equals negative x plus 4, meaning it has a slope of negative 1 and a y-intercept of positive 4. And if we look at the intersection point where the two cross, the coordinate pair of that point is 1, 3, meaning it has an x value of 1 and a y value of 3. Let's look at a word problem. Keita and Ben want to hang out for the afternoon. Ben leaves his house walking at 3 miles per hour, and Keita leaves her house at the same time riding her bike at 10 miles per hour. If their houses are 6.5 miles apart and they are traveling straight towards each other, how long will it take before they meet? So the first thing we have to do is create equations. So for Keita, we'll do y equals 10x. In other words, the distance she travels is equal to 10 times the amount of time she's traveling. So it has a rate of 10. And for Ben, we'll do y equals negative 3x plus 6.5. Again, his rate is 3, but it's negative because he's going in the opposite direction. He's going to meet her. And he's starting 6.5 miles away. When we graph these, we see that they intercept each other at a point 0.5 and 5. So this is a coordinate pair of the solution. Now what we want to know here is the time at which they intercept. The time is 0.5. So if we put this into a word answer, how long before they meet, Keita and Ben will meet in half an hour. Here's another word problem. Sasha and Raj both have swimming pools that they want to fill. Sasha's pool holds 6,000 gallons and fills at a rate of 50 gallons per minute. Raj's pool holds 10,000 gallons and fills at a rate of 60 gallons per minute. If they both begin filling the pools at the same time, at what point do they have the same amount of water? So again, we need to create equations. For Sasha, we can do y equals 50x because there will be 50 times as many gallons as there are minutes. And for Raj, it'll be the same except for the rate is 60, not 50. When we graph these, we see that they intercept at the origin, 0, 0. This means that the only time they will have the same amount of water is right when they begin to fill. So the word answer to the problem is when they begin filling the pools. So the pros of solving graphically are that it's very easy to visualize. And in some cases, it's easy to figure out too. The cons are that it is often inaccurate. In some simple equations, you will actually get nice, obvious intercepts. But lots of the times, they'll be in an area where there is no obvious reference point, so it's hard to be very exact with an answer. The other problem is that it can be time-consuming to create a graph and then read it. So take some time and get used to working with reading and creating graphs from equations.